In defense of national security and maintaining freedom of the seas, the U.S. Navy's ability to detect enemy submarines is essential. The Navy can use passive sonar to listen for enemy subs, but passive sonar is becoming increasingly ineffective as modern subs become quieter and ambient noise in the ocean increases. This makes the use of active sonar the key technology for anti-submarine warfare.
During active sonar, we're actually sending out a signal, and that gives us their bearing, their course, and their range, which is imperative for us to fire.
So active sonar is sometimes the only way to find them. It could be the one thing that could be the game changer in the end.
To be effective at identifying and tracking submarines, sonar operators need to train as they would operate during real-world combat situations.
Training is paramount. The sonar technicians must absolutely be on their A game to be able to thwart the threat.
Training with active sonar has the potential to impact marine life. To avoid impacts, the Navy follows a strictly defined set of mitigation measures, such as maintaining lookouts and powering down or turning off active sonar transmission if a marine mammal or sea turtle is sighted within a mitigation zone.
Sonar, port bridge wing. I've sighted potted dolphins, relative bearing 270 off the port side.
Bridge sonar, dolphins are sighted. Secure sonar.
It is all about utilization, but safe utilization for not only human beings, but the other creatures that inhabit the oceans.
Active sonar is secured.
The Navy has sponsored research and monitoring to better understand the potential impacts of active sonar on marine mammals for decades. Research on the potential impacts of sonar on other species, such as fish, is currently very limited. Improving baseline information will help the Navy better understand and reduce potential impacts of its training and testing activities on fish communities. Today, the Navy is working closely with the Rhode Island Department of Environmental Management to collect and study wild herring.
We're looking at potential changes to behavior of the fish and looking at metrics such as changes in swim speed and habituation and group spread.
It's important to conserve herring because they are so important to the freshwater and marine ecosystems. So as we see today, a lot of the juvenile fish are using the fishway to exit out of the river and into the ocean.
Small schooling fish like river herring are important to maintain healthy ocean food webs and are sources of food for larger fish, birds, and even marine mammals. River herring spend the majority of their adult lives at sea, but travel into freshwater rivers, lakes, and streams to their ancestral spawning grounds to reproduce in the spring. Here at Indian Lake, Rhode Island, that migration pattern has allowed researchers an efficient means to collect and study these fish in two distinct life stages: adults in the spring, and now juveniles in the fall.
Morning.
Morning.
What a day you guys have.
I know, I can't even believe it. There's so many fish this year.
Back at the Navy's research docks a few miles away at the Naval Undersea Warfare Center in Newport, biologists began a controlled exposure experiment. Using an active sonar source positioned just outside of the juvenile's pen, while video captures fish behavior for later statistical analysis. What makes river herring interesting to Navy scientists is they are among the few species of fish that can hear sounds in the Navy's mid-frequency active sonar range.
The Navy uses mid-frequency, which is between 1 and 10 kilohertz, for their training and testing exercises. And the river herring can hear between 1 and 10 kilohertz, whereas most any other fish species can't hear above a kilohertz.
With these experiments, scientists are working to find what, if any, sonar exposure level causes a behavioral response, injury, or mortality, and how impacts differ between life stages.
This behavioral study on herring is really important because it feeds into our mitigation and compliance efforts, but also helps the scientific community understand what is going on with these animals.
The test setup that we have for controlled exposures of the river herring is actually a worst-case scenario where we have pen fish directly adjacent to the sound source. In a natural environment, the fish would likely be at a further distance and also have the ability to flee the area.
After completing the behavioral experiments, the team retains a subsample of the herring for laboratory examination.
We look for hemorrhaging or hematomas like blood or bruising, and then we also look for embolism, some air bubbles. And we'll look internally and externally.
The team also analyzes the videos over the fish pen to observe and measure if the herring react behaviorally to the sonar test pulses.
One thing we're also looking at with these fish is whether the longer they hear a sound, do they start to get used to that sound? They habituate to it. So what this shows you is for each little signal within that whole playback stimulus, when they first hear it, the swim speed increased quite a bit. So there was a big response to that very first signal. But by the last signal in that sequence, there's no real change in their response. So we're not seeing them behaviorally respond anymore, which indicates that perhaps they're habituating or they're getting used to that signal.
We've also seen a difference in the amount of habituation between the different size classes. Now we are looking to further investigate what is the lowest level of sound exposure that elicits a response for the fish.
We're still in the very early phases of this research, but we can say that the initial results are promising. It looks like there may be some habituation to the sound, which could mean that long-term impacts are minimized. It is still early. There needs to be more research into this, and we're really excited about pushing forward the science here.
The Navy hopes that its efforts to better understand the river herring will have a positive benefit for the conservation of this important species, as well as the freshwater and ocean ecosystems in which they live.
It is important that the Navy is involved in conducting research throughout the entire life cycle chain, if you will, to know exactly how we do or do not impact that environment and those species.